everyone, this is Team 11. Today we will give our presentation on Scenario 2 group project about heap sort tool. Firstly, I will talk about the overview of our project. Our project is aimed to help students to have a better understanding of heap sort algorithm by doing some exercises, as well as some new exercises could be designed by teachers. For those who are not so familiar with the heap sort algorithm, our tool gives a more intuitive way to visualize how each step of sort has been done. The users could get a more in-depth learning of the algorithm by moving the nodes on binary tree on their own. Heap sort shows some good performance compared with other sorting algorithms. It is more time efficiently compared with quicksort and more space efficiently compared with merge sort. Heap sort is mainly used to constructing a priority queue, which is trying to find the tasks with highest priority among huge numbers of tasks. Also on the interval scheduling, heap sort helps a lot, which idea is to find out as many tasks as possible, which could finish within a given time period. Thus, using our tool to get a more comprehensive understanding of heap sort helps for the future use on its applications. During the implementation of the project, we use Weixin for our group communication. We exchange ideas and post our progress in the group chat. We also use GitHub to collaborate and integrate our code.
This is the overview of our project historical version. In our initial plan, we decided to use a Python library called Graphis to make our tree diagram, and the Kinter library to build our user interface. The graph will be generated like this picture. The picture here, the first picture, the user can input the answer to the question in the list below the tree diagram. But soon we decline this plan because we consider that it will be better to let users swap the nodes by clicking instead of typing every time, as it is too abstract. And we also decided not to use the Graphis library. The reason is that the graph generated by Graphis is not drawable. We couldn't change the graph instantaneously when needed. For instance, if we want to change the color of the node when we click on the node, it is not achievable. Then we decided to use the Pygame library instead, because Pygame is a support library for making games. This means that the graph drawing function is very powerful and can satisfy our requirement. But when we researched how to build a graphic user interface on Pygame, we found that the support for GUI in Pygame is very weak, which makes it much harder to create a satisfiable UI with this library, as it is a library for making games, not for GUI. Finally, we move our step back to Kinter, as it can build GUI much easier, and it also has a drawing support class Canvas. Although it is not as powerful as Pygame, but it meets our needs. We actually don't need to draw complex graphs, so it is not a problem. The design prototype is like this, the second picture here. In actual programming, we found that it is much more difficult to implement a tab component switch between the do and design page. So we decided to use a front page with two switching buttons instead. The actual software is like the picture shown.
And here's a quick demonstration of heap sort tool. Let's run the program. And this is the starting page. You can click how to use this tool to check on some instructions on designing exercises and doing exercises. Now let's say I want to design a new exercise. Click here, and in this exercise repository, there are some exercises that already been created. And if I want to create a new exercise, click here, and you are asked to input some integer numbers in the correct format. If you input something weird, it's not gonna be accepted. Okay, let's say I want to input 1, 0, -2. and then input the exercise name. Again, validation check is applied. Okay, new exercise is now in your repository. And if you restart the program, the exercise is still here because it is stored in the database. Now I want to solve this exercise. Click Do Exercise button and click on the exercise you want to solve. In this case, I want to solve new exercises. And if you don't know how to do that, you can click Want Some Hints button. And this is a very basic pseudocode for heap sort algorithm. Okay, now let me try to solve this. You can click two nodes respectively to swap their position. And if this node is already in its correct position, the link just disappears. And if you do some invalid swap, you will be notified, and this swap will not be valid. And after you solve this exercise, the exercise name in the repository will have a suffix solved, so that you know it is solved. If I want to delete some exercise, click Design Exercise button, choose the exercise you want to delete. In this case, I want to delete the new exercise. Click Delete this exercise, and now it's gone. Okay, so this is pretty much how this tool works. Okay, now let's move on to the problems and some things to improve on. The most significant problem is the design pattern of the code. At the start, we plan to use the MVC pattern, model view control. However, it turns out that it's not that easy to implement it. As the codes expand and committed by different members, the model and view parts are kind of mixed up with one another, which makes the code not extremely easy to be read. And this also gives rise to the version control problem. As most of us are not extremely experienced in group projects or version control, sometimes it's really painful to solve the conflicts. And I think in this project, we should have done better at planning the model and the pattern more carefully, and maybe make a few diagrams before start coding and assigning jobs to different members.
Finally, if we want to extend our tool, we would like to add some useful functions. For example, we could add a part for users to write their feedbacks and suggestions, such as the problems about user interface design or the interaction with tool. Apart from that, we would like to add a timer to record how long the user takes to solve an issue. The user could know their mastery of each exercise and challenge themselves to use shorter time to solve the problems. Okay, so that's the end of our group project demonstration. Thanks for watching.